That again? Hi, I'm Mike Davis. I'm probably better known to people as FAR. I'm going to be talking today about secure instant messaging, but I guess before I do, I just want to say I appreciate being here. I really enjoy the Congress far more than I have any of the American conferences I've been to, except maybe PumpCon. So what I'm going to be talking about today, whenever the focus works. Focus! Well, to get started a little bit before the screen is actually focused a little bit, I'm going to be talking about secure instant messaging. More specifically, a slightly more business-oriented talk towards what are some of the problems with instant messaging, as far as security concerns, how some of the companies have actually addressed these security concerns, and maybe where they fall short in the end. I also plan to and try to make time for showing off a format string exploit in the current version of Aol Instant Messenger, and before anyone actually asks me, no, I haven't actually notified AOL of the flaw, but it's okay because it's not a flaw that can be exploited remotely without remote local access to the network that the client's running on. But I'll show that off a little bit later. So let's see, start. I don't know my own slides. Be talking about a brief history of instant messaging. Some of the attacks against it, some of the older attacks, and a lot of the newer attacks, how instant messaging is being used today, and current problems, and, well, to-do list for open source developers, which has kind of been removed from the talk, but hey, last minute changes. To begin with, my qualifications for giving this talk is that in 1999 and 2000, I began writing what is believed to be the first secure instant messaging client for Aol Instant Messenger. This was a C-based plugin for the game open source messenger. It was a 248-bit Diffie-Hellman encryption and 448-bit blowfish. It earned me my first cease and desist from America Online. Apparently at the time they weren't very happy to have anyone playing with their protocol. But really, this was a silly hack. It was meant to be a joke. At the time, nobody was taking instant messaging security seriously. Nobody really cared if their instant messages were sniffed. Everybody kind of treated AOL Instant Messenger, ICQ, Powwow, some of these other messengers that were out there as, toy software, the way you would treat software like WeatherBug or, something like that that's just running on your system and, you use it every now and then. The problem is that security has become an issue with instant messaging as businesses have started using it and using it almost more than their phones or any other medium that they use, possibly even more than their website. So, of course, when you have something that's a joke and, starts working out and people take it seriously, you have to try to make a business out of it. So I started Impasse. Impasse, secure messaging proxy, used RSA, blowfish, the same sort of things, except I ported it to all three protocols. The unique thing about Impasse itself is that it was a proxy. Is a SOX 4, SOX 5 proxy that would actually take the protocol of each instant messenger apart packet by packet, removing clear text and replacing it with a flagged encrypted packet that was encoded in whatever way was necessary for the network. For MSN's case, it was encoded in HTML. In AOL's case, it was encoded in binary, and in ICQ's case, it was armored base 64. All of these protocols were reverse engineered cleanly, so before anyone tries to sue me, I did it the right way. These protocols were also not based on any of the open source messengers. Okay. So to begin with, IRC was probably our first instant messenger. It's not really what we think of as instant messaging today. You really didn't have things like presence awareness. You didn't have, a lot of the features that we've come to think of in instant messaging. Popping a little pop-up window that comes up every time somebody messages you. It was more centered around the group chat kind of feature and things like that. So way back, and I wasn't able to actually find out when, AOL introduced the first instant messenger. It was only available to customers of the AOL software who were using the actual AOL service. People would message back and forth. And at the time, people thought this was so neat that they would actually, they actually believed and passed around rumors that these instant messages cost 10 cents a piece. It's really kind of funny. 1996, Mirabilis wrote ICQ. This was probably one of the first internet-based messengers. The protocol was a UDP protocol. It was meant to be connectionless, lossy, not really very reliable in any way. But it really defined the way that instant messaging works today. We have our buddy list, we have presence awareness, we have offline messaging, we have games and sharing multimedia files and all of those things. In 1997, AOL didn't want to feel left out of this kind of thing, so they launched their AOL Instant Messenger and automatically allowed all of their users to sign on to this instant messenger and talk to people on the internet, and anybody could register a screen name and hop onto AOL's instant messenger service and talk to people who were on AOL. It was very fun. I have to admit I was part of this little fad. But in 1998, AOL decided that they had to be the only company that was running instant messenger services. So they purchased Mirabilis and formed basically the largest internet messaging provider. But that wasn't quite enough. They had to actually replace the entire protocol out from underneath the Mirabilis client, replacing it with their more native Oscar protocol. Soon after, Excite, Yahoo, MSN, Powwow, all of these other messengers that have kind of popped up since then. I mean, there's a million and one out there. I work for one currently now, which I won't mention because I want to keep a job when I get back to the US. All of these messengers are kind of out there, and people use them in various ways. A lot of companies use them for very serious things like communicating important messages, sending passwords back and forth. My God. There's a lot of these things. Credit card numbers. I actually have AIM logs with credit card numbers that are in them that I just snarfed off the network with ngrep. So it's really a new kind of idea that instant messaging now is something that people should fear. So as I was saying before, instant messaging, early instant messaging was considered novelty or kitsch. Nobody really thought of it. A lot of the attacks that were against AOL Instant Messenger or the other clients were mostly to annoy people. Things that would crash clients, things that would slow the computer down to crawls. For example, HTML open braces, or whatever you want to call them. If you kept feeding the client open braces over and over and over again, it would allocate the space for the HTML tag. And if you sent packet after packet of these open braces, the client would eventually consume all of the memory of the system and crash. Usage since then has kind of evolved. I'm sure all of you know what AOL Instant Messenger is, or you wouldn't really be here. And I'm sure most of you use this in your company unless your company has a specific policy. In which case, I believe your policy is probably something similar to don't use any of these instant messengers online. So the early attacks against these instant messengers were things like AOL bombs. Sending large numbers of instant messages, either from one person or from multiple people, over and over again to fill the screen of the person who you were attacking. Really, it was just annoyance. It would knock people offline. It would crash their clients. In some cases, with the AOL client-based software, it would actually crash the entire client, taking the user offline altogether. It was really a funny time. These patches were usually fixed by AOL relatively quickly, and at the time, relatively quickly being a number of weeks, possibly months for some of these. I remember being booted offline many times. I already talked about HTML formatting flaws. One of the really big ones is the AIM URL handler. This is something America Online introduced, and I think is one of the most moronic features of instant messaging that you can possibly have. These URLs, if nobody has used them, they allow you to do things like change your buddy icon. They allow you to click on links on web pages and have these links activate different features of the AOL software, bringing you into chat rooms, opening up IMs to people, taking you to specific AOL-centric type stuff, even giving you software updates. The problem with this is that they were implemented pretty hastily, and a lot of these things could allow you to forcibly change people's buddy icons, and they'd never noticed because they didn't have a local copy of their buddy icon. They were never really sure what they were sending out, which ended in some really funny conversations. These AIM handlers are especially a problem, not so much then, but they are now, because these AIM handlers would allow you to invoke the AOL client whether or not the client was running. The AIM handler would then call a DLL and would pass all of the parameters that you've given it to an AIM DLL, and if that DLL is exploitable, you have the possibility of arbitrary code execution. So this is a very short list. I challenge you all to go to Security Focus. I have a local database that I used and actually typed this up last night, but this is a list of exploits. Again, some of the older clients, some of these are old ones, some of these are current ones. All of these are remote denial of service attacks or unauthorized access to remote files, the ability to grab files from the remote user, force the user to download and execute programs. The MSN one, that's really important on that one in today's instant messaging environment is probably being able to send messages as an arbitrary user and have that message actually come back to you when they reply to it. It's a disturbing feature. Microsoft. All right, so I really shouldn't need to explain this. Why is instant messaging important to you? Well, in case you don't know, or if you haven't checked all of your instant messages, unless you're using something specifically chosen to encrypt your packets, all of these packets are sent in the clear text. There's nothing really guarding it. Again, when these instant messaging protocols were initially invented, they weren't really considering things like security and privacy. They didn't really think that sniffing off of the network was a plausible attack against instant messengers. It was really just a way to send a message to a friend and say hi. The other problems are you can basically steal somebody's identity if you can get them to give you files or get them to give you information. On AOL, this was known as phishing, and I guess this is also known in general now as phishing. You steal people's information, you convince them you're somebody else, they give you their information, and then whoop, you become them. If compromised, your system can be used to carry out attacks. This is all kind of standard stuff that we should all know and love, maybe. So when it comes to businesses, they've actually found a wider use for instant messaging than maybe people at home have. People at home really don't need to worry about security much more than worrying about buffer overflows, worrying about being exploited, being used as a spam host, being taken advantage of in the many ways that I guess you can be taken advantage of. But businesses actually have started doing things like using this for inter-office communications. The problem with some of these is most of the servers or most of the messaging clients are server-based. They're centralized servers. All of your messages, whether they're going to the person sitting next to you or the person who's sitting in, another office somewhere, are going through the AOL server and then they're going back to that client on the other end. And when doing this, it may be traveling over wireless networks, it may be traveling over unprotected networks. Who knows? Do you trust your ISP? Instant messaging can be sniffed wirelessly. Possible leakage of company infrastructure. This is something a lot of people don't really talk about very much, but instant messaging gives you a better channel for using something like, I forget the word for it, but social engineering, right? You have better access to the company infrastructure through instant messaging through instant messaging, and you can perform more sophisticated social engineering tasks if you can simply convince the person on the other end that you're somebody you work with. And in this case, through instant messaging, it's much easier since you don't have to sound like them or even know them. You can just make a screen name that looks remotely like somebody who works there and send the message and say, could you give me the root password on that box? I forgot it. It also, let's see, employee contact outside of the working. There's no way to monitor or enforce company policy regarding contact with customers or partners. And I guess before I hear anybody maybe criticize the idea of monitoring instant messaging, in some cases in the United States, for things like SEC compliance, there's also, I guess, HIPAA compliance. There's a few types of cases where all instant messaging, all communications with customers and other businesses need to be logged. You also, as a company, need to be sure that somebody in your company isn't yeah, I guess being rude to customers, deliberately causing problems within the company, and there's no way to say things like, please don't download files, please don't, join chat rooms and things like that. So one of the things that's missing is a way of enforcing these policies for instant messaging clients. As it works now, most secure messaging clients will tell you what you have to do is basically black hole AOL.com and Yahoo.com and MSN.com and every other instant messenger.com and not allow any traffic, HTTP or otherwise, to that client, because each and every one of these clients is actually specifically designed to circumvent your firewall restrictions. They will use HTTP, they will use HTTPS, they will use just about anything to actually talk to the server over any port that will talk to the client, or any port that will make it through your firewall. Again, why we should all care about instant messaging, these are things that kind of overlap. The prevalence in so many homes and offices. The idea of that is that instant messaging is so ubiquitous. Everybody uses instant messaging, and by far everyone uses AIM probably more than they use any other protocol. The problem with this, and the problem with AOL's policy of actually requiring you to use only their client, is that you have one bit of software, and if it's currently, every client who's installed is current and up to date, and there's an exploit found, each and every one of those clients that has now just circumvented your firewall has the ability of bringing an attacker onto your network through something as simple as an instant message, and I can verify this through security-focused articles, through buddy icons, malformed buddy icons, large buddy icons, integer overflows, buffer overflows, things like that. It allows an attacker remote access to your network because you've allowed this protocol to tunnel over your firewall. You've given them an in to your network. I guess I've talked a lot about this. Companies have what these sanctioned uses of instant messaging are. Status reports, ad hoc online meetings, people getting together when they're in different places to talk about the things that are relevant to the company. It's not a bad idea. I think everybody uses it. The problem is that all of these clients just really still have the model in mind of mom and daughter talking about Christmas dinner, not really people talking about real serious issues over AIM, things that would actually affect the security of the company or the privacy of a company or the intellectual property of a company in some cases, and I'm going to talk about that a little bit. The unsanctioned uses. Well, since we've all got AOL Instant Messenger in our offices, I'm sure we've all used it for these types of things. Primary means of communications. I know I'm personally guilty of this. I have an SSH shell open almost constantly using the console client name to talk to people. I do this in my entire day at work, probably spending more time talking to people than I do actually writing code. Playing games, chatting in rooms, and doing all of these other things that you really don't want to have done at your company, but you have to accept that people will do this. And if you're going to have a company that is requiring things like logging of all instant messages, this is the kind of thing that you want to take into account, whether you want to block these types of things or whether or not you want to actually isolate these sorts of things from the actual business messaging end of the things. Well, I apparently used the wrong slide for this, but some of the things that were supposed to go here were some of the instant messaging problems that have actually gone wrong. I may actually have this in the next slide. No. There was a company called eFront. eFront at one point had a penetration into their network. The CEO's desktop computer was penetrated through a, quote, unknown method. What the attacker actually took was a log of the ICQ messages of the CEO. The attack I believe that they used was an arbitrary, being able to access arbitrary files through ICQ, but the files had to be in specific directories, and more specifically, probably ICQ directory files or any files that were listed in the user's path. So, yeah, there's nothing actually up there. So eFront, what happened with them was that they were an advertising firm, and these instant messages were stolen, and these instant messages were posted onto websites, essentially revealing the scandal. The company was failing. Internet advertising was a failing business plan, and they were talking about how they can solve this problem and various nefarious ways of solving that problem. When these instant message logs actually hit the internet, what happened was all of their financial backers pulled out, everybody lost faith in the company, and the company essentially bombed. The other incident I was going to cite was a company, and I can't think of the name, Bug Toaster. It's a really cool company name. What Bug Toaster did was they found a flaw under Windows 95, 98 ME that allowed a user to recover the MSN passport in clear text because it was stored in a documented place in memory where Windows dial-up networking actually stored passwords to pass it on to other programs. You could recover this password, and because of the plan that AOL has for these passports, if anybody doesn't know, it's to use it with your e-wallet, to use it with just about any service that Microsoft has been able to push their passport technology to log into. If an attacker gained this, they would gain access to your bank accounts, your Hotmail accounts, and anything else that would take a passport login. This is a really extremely dangerous issue. But these are things that have kind of been fixed, and these are the only big issues that have actually hit the internet as far as logs being stolen and being published. I'm sure the more real problems have been data theft. Speaking of data theft, in this past year we had the HOPE conference in New York, where I was a big part of dealing with a lot of the stuff. I was actually on the network operations staff. And being on the network operations staff, I had access to the gateway router. What I did on the gateway router at the HOPE conference was I installed a TCP dump rule and dumped to a file each and every instant message that was ever used on the entire network through the entire conference. What we have here are two instant messages from somebody I think we call Captain Crunch. If you look at the first packet here, and I'll be talking some more about this particular packet later, the first packet is the packet that's immediately sent after sign-on. This is an abbreviated packet since he's using a Mac client, and if I had included the earlier version, I could tell you that exactly what client he was using. I mean, I know he was using the iChat client, I know exactly what version of the iChat client, and I know that it was also a vulnerable version of the iChat client. Things that are in this packet are, for example, are the URL. If you notice this URL here, this URL tells the client when you select the change password option in their menu where the user should be sent. And if you notice the screen name equals, if anybody has done any format string exploits, you'll notice there's a %s in this string. That's stupid. Okay. We'll talk about that one later. The other packet here is something else I noticed about the iChat client, and I don't know that I'm fully prepared to talk about this in its entirety, but this is something I noticed this morning when preparing the slide. This is a packet at HOPE that, again, Captain Crunch had sent when talking to his new masters about a website that he was preparing. I don't really know why he was doing HTML rather than programming, but this is apparently what he does now. File transfers are actually done in instant messaging packets. I was able to recover an entire HTML document and a couple of images that were sent to his company. And were I actually exploiting this, I could have replaced and altered those files. At the time, the Microsoft JPEG parser was an issue. I could have easily replaced this JPEG parser with an exploitable image. If you don't notice the email address for Captain Crunch there, it's shopip.com. What they sell there is secure IDS-based firewalls. This is a person who takes security seriously. So if I could have replaced on their site, and I believe this page, I didn't include the rest of the packets, I only included the single packet. The rest of this message, if I had replaced the image with an exploitable version of the image, essentially what would have happened is I could have had root access to each and every one, well, not root access, I guess administrator access, to each and every one of the machines that actually viewed the page. So that's everybody that's configuring their secure firewalls. This is actually a bit of the snippet of the HTML file. Sorry, I mixed up this with the other slide. And you'll notice that the crunch box, this is where I talk about the leakage of information that probably shouldn't be publicly available. The Crunch box is advertised as a box that is written by Captain Crunch, the man who takes security seriously. But if we look at the comment at the very top, the Crunch box designed and programmed by Stephen Innes of ShopIP. This is a company that actively sought out Captain Crunch and used his name to produce a product. Now, I feel comfortable saying this out loud because this is true. This is a message that has not been altered. This is a message that I grabbed legally. This is a message that I had easy access to. I have now revealed more information than is probably known about the Crunch box at all. Not a big deal, right? So, all right. So in the marketplace, a lot of people have started taking instant messaging seriously. They notice that people are using instant messaging. Everybody has kind of latched on to, I guess, my idea of securing instant messaging and encrypting things. But companies tend to mitigate these problems. So you end up with things as strong encryption, logging for SEC compliance, verified user identification, secured file transfers, hierarchical policy management, online meeting tools. But no client actually combines these things. And most of the clients, all save for two, and the one is Skype, and I don't remember the other one, that actually use strong encryption for their messages. The rest use SSL-based encryption, and I'm sure if you asked MIT how that SSL-based encryption works, they'd tell you that it's probably ridiculous that you're using your credit card number online. So none of these clients are actually putting all of these things together, and nobody's providing a messenger for business, for the use of business, and on the side for messaging from business people to individual people. So these clients need to be taken seriously. I mean, it's not really something that I should have to request. These clients need to be audited. If not now, at some point, these protocols need to be based on proven security models, X509 certificates that are signed by the main host and a signing authority, and then each certificate delegated to each of the users. And I mean, whatever scheme you want to think up, I don't want to really put forth a half-baked plan. But what is existing now is just insufficient. It's stupid. It's really a feel-good maneuver. It's like being X-rayed at the airport. You go through the metal detector and they say, we're sure you don't have any metal knives on you, but you may still have a plastic knife. We can't really tell. We're not checking for that. None of these protocols are actually open standards. At one point, the IETF had gotten together to try to come together on a protocol, a way of providing presence management, a way of providing messaging, not so much cross-platform, but for anybody who wanted to provide a messaging client. The problem is that this IETF work group never actually decided on a standard. They were unable to come to an agreement. I should also mention that the companies that were involved were a number of individual users, as well as AOL, Yahoo, MSN. I don't believe Jabber was included in this. It might have been too early for Jabber. There are currently no standards for interoperability amongst the clients. The big problem now is that all of these messengers are trying to fight for clients. They want to force clients to jump from one messaging network to another. AOL, for example, wanted to force all of the Mirabilis users onto their network, and they were able to do that by purchasing the company. However, they weren't able to force all of the Microsoft users or all of the Yahoo users or all of, well, any other users to do that. So, I mean, a lot of the things they did were trying to keep out other open source clients. They wanted to preserve their business model of sending advertising to users, being able to present some sort of method of making revenue through advertising. And by doing that, they have fought over protocols. They haven't really decided on a way of even delivering message from one network to another. And since as instant messaging has become a new communications means, this is really something that needs to be done. You need to be able to send a message to an AIM user from an MSN account. You need to be able to send a message to an MSN user from a Yahoo account. If AOL is ever going to be taken seriously and used for things like online shopping or discussing passwords or things like that, these are things that need to happen. You can't form an advertising model around people who simply need to communicate in their office. You base it on the client. You make people come to you because your client is superior. AOL, for example, when MSN had tried adapting its client to use the Oscar protocol, AOL began doing things like tweaking its protocol so that the MSN messenger couldn't keep up and couldn't parse the packets properly. The reason they were able to do this is because AOL doesn't parse their own packets properly. These packets are actually stored in what's called a TLV, the type length variable. The type is, I believe, a 16-bit variable, and the length is another 16-bit variable, and then followed by that is the actual data. In these packets, the way that AOL searches through them is they search for a TLV that they believe to exist in a packet, and they zero in on it. MSN was unable to parse this because what happened was they would parse individual TLV after TLV, and sometimes there are sub-TLVs and sub-TLVs and sub-TLVs. I mean, you could potentially have a very large tree structure from this sort of thing. So they introduced these flaws in their protocol to force the MSN client to crash. The problem with this is that you're not able to create an MSN protocol verifier in any way. You can't verify that you're not being exploited because you're not sure that exploit isn't being used by AOL to actually verify that you're using an AOL client. They have been happy to use things like buffer overflows to grab bits of data that existed somewhere else on the stack. They have been happy to send you MD5 signature, or requests for MD5 signatures of certain portions of your program and other things like that. It's just ridiculous. Stop fighting over these little protocols and bickering over this stuff. After that tangent, client and corporate installations have no way of distinguishing between personal and private instant messaging. And in some cases, you'll want to enforce rules like, I don't want to allow any curses or any sort of derogatory language to go through these instant messages, or I want all of these instant messages to other clients, or all of these instant messages that talk to our broker to be logged. I want them to be logged on optical media. You have no way of distinguishing between them, and so people will just use one client and decide to go with that. So yeah, wait for Microsoft. No, not really. Really what you can do for these kinds of things is simply wait for a lot of these messenger clients to actually take messaging seriously, but you have to really force these kind of people to do this. But until then, what you can do is practice, standard safe computing practices. Don't give people your root password over Instant Messenger. Don't give people any password over Instant Messenger. Heck, don't even talk about your company over Instant Messenger unless you're damn sure that message is not going out on the internet and is secured and is privatized, and that information is not going to cause your company any irreparable harm. Consider using different usernames at work and at home. This is a really big issue because things like stealing people's passwords and masquerading as that user and then using that for a social engineering exploit. I mean, it's the equivalent of stealing somebody's face and using that to walk into an office without any sort of issues. Never save any, or never share any sensitive information over IM, secret plans for world domination, Dick Cheney's location. I guess you can tell I'm from America. So, all hope is not lost. There are improvements in instant messaging. AOL has recently started to allow you, though it's not documented, to use X509 certificates, individual user certificates, so basically SSL, over their messaging client. But to do this, it's a bit of a pain in the ass, and you have to go get a thought certificate, and well, you have to make sure that each and every other person that you want to talk to securely also has a thought certificate, and this fits really well into Thought's pricing model of, a simple $19.95 a month kind of plan. Let's see, we're getting towards the end. I don't actually want to get to questions yet. What I actually want to show you now is the format string exploit. What I had intended to do, there's my debugger. What I had intended to do was show you that an actual format string exploit and, provide you with a shell. Unfortunately, I just wasn't able to have enough time to do that. But what I'm going to show you is where the actual format string flaw exists and prove to you that it can be exploited in a live manner. And hopefully I have network to be able to do this. Jen, your AIM name is still in here. Jesus. Let's see. So we're going to use my AIM name. Please don't nag the hell out of me. So what I'm going to do is sign on to AOL, and I'll log in with a proper password, hopefully. Whatever, it's my laptop. This client will hopefully connect, and what I'll get from AOL is that this client is a one version out of date. Oh, there we go. We've hit our debug trap. This packet is, as you can kind of see in my commented out code, this is bits of code from Impasse that I had used previously. Maybe you can't see this too well. This is a family 17 subtype 3. If anybody knows anything about the Oscar protocol, or if you want to dig it up, you can look up LIB FAME documentation. You can see this sort of stuff. But what I can do, maybe I can't do this because I'm not paying attention, is I can view this packet in RAM and modify the URL that's used for changing my password. And what I'm going to do is actually replace this with %x, %x, %x. I hate this debugger sometimes. %x, 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 Okay, so now I'm going to send that packet on the way by continuing execution. And the AOL client should log on successfully and not really notice that I've modified the packet in any way, because I haven't actually modified the length of the TLV structure. If I had done that, I would actually need to modify the encapsulation of the flap header to tell it that my packet is going to be longer, and I would need to modify the TLV of that actual packet that I modified. This really slow computer running under VMware. I'm really sorry. So what I'm going to do now is pretend that somebody told me to change my password, and I'm going to edit options and change my password. Oh look, AIM crashed. Wonder why. If I had had the Visual Studio Development Kit installed, what I would have seen is a segmentation fault. What I just did was pop values off the stack. For anybody who doesn't know what a format string flaw is, each time I include a token of %s, %x, %u, these types of tokens, I'm popping values off of the stack, and I can basically search through memory like that. What this kind of allows me to do is it allows me to replace their URL with an entire format string that would allow me to search through their memory space for EIP, and it would allow me to insert shellcode, and it will allow me to insert the address of that shellcode, since that address is now on the stack, and begin executing that code. I've now exploited the system. Unfortunately, it's not very impressive here because I wasn't able to get, there it crashed. I wasn't able to get the actual MSN client to, or the actual Visual Studio installed and have it actually do that. Maybe I can try this again. Oh no, it's the wrong hyperlink. So what I'm going to do now is I'm going to attach to the process through the debugger, maybe, except my slide is coming back. I'll attach to the process of the AOL Messenger, and hopefully we'll see the area of code where it actually breaks. If anybody actually wants to go home and do something like this, all you really have to do is use a library like Packet Purgatory and some ARP spoofing. You really only have to make the client think that you're the gateway, and then relay packets. That's exactly what this Impasse software does. The software, instead of actually emulating the gateway, what it does is it sets up a SOX 4, SOX 5 proxy, and each of the packets go through me. It's a very simple way for me to explain this exploit to you without having to resort to setting up alternative machines and Unix systems and packet, basically re-implementing code I've already written. Oh, there's our debug point again. As you can see, I can edit this by hand. It doesn't really have to be real time in any way. Percent U, percent U, attached to this here. Aol AIM protocol. Attached to the process. And there we go. We're loading the DLLs for that system. Now we should send this packet on its way before the connection breaks. If I can find that window. Somewhere in here. And AIM-EXE reloads some DLLs and loads a lot of DLLs. Loads a whole lot of DLLs. I didn't actually get to change the packet. Well, I believe I missed that packet actually as I was redoing that. But the idea is that if I only modify the URL slightly, what it will give me without crashing the actual client is it will give me addresses off of the stack. Standard approach is at actually exploiting format string flaws for a version that's unknown. And the reason I mention that is because every version since they've actually implemented the change password feature is actually exploitable to this flaw. You can pop addresses off the stack and find where your buffer is and build a buffer overflow specific to that version, even though there are 50 billion different versions of this actual client. The software will segfault, or if you choose not to segfault it, you can redirect them to a URL. When they go to change password, that URL will have %x, 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 and that URL will be submitted to your website. So each and every time you modify this packet, they will go to your website and send you the data of what's on their stack and what address you've actually hit. So you'll find their EIP and be able to exploit them even live if you chose to do so. So at that, I guess I'll leave it at questions. Could you find a microphone, I guess, somewhere? Okay. Could somebody turn his microphone on?
I think it's on. Okay, hi. Just two comments.
Yes.
One thing I think you haven't focused on yet is instant messaging is a really informal protocol. It was supposed to be very informal. Like I'm standing in a bar and I'm talking to somebody and I might say, gee, Captain Crunch is a moron. But it's not something that I want to have some sort of evidence or logged or in your case, since you're promoting X519, have a digitally signed packet that says, Paul says Captain Crunch is a moron. So one thing that's missing is is that you want the security without private keys, and you want the deniability that you've said something like this. And actually, I'm not sure if you've seen the Canadian cypherpunks have actually recently released a plugin and a library called OTR, off-the-record messaging, which implements both deniability and the fact that it's not using keys, public-private keys, to sign your message. One of the cool things of this protocol is also that it allows anybody to forge messages of you in the past, but because it's changing a development key every message, you still know that you're secure.
Right. Well, one of the things that I was trying to make clear, I guess I really haven't succeeded very well at it, is that I'm not trying to say secure instant messaging from a hacker standpoint. I'm not trying to give deniability. What I'm trying to point out are some of the flaws when instant messaging is used as far as a business sense. What I'm trying to say is instant messengers need to be protected from people forging messages in the past. They need to not so much have actually signed packets. I only throw X509 in there as an example of what should be done. I personally went with Diffie-Hellman and disposable keys, where each key would be just tossed when you close the connection. There was no way to really tie that key to you. But in the case of business messaging, each of these messages does have to be verified that they came from an individual user. each of these messages does need to say that it came from this user at this time, I actually said this, and there has to be a traceable log of all of that type of information. But I understand what you're saying, yes, it is absolutely different. And I recommend plugins for things like that, like you were saying, the OTR and Game E, I think, is what a lot of people use now for things like that.
Yeah, OTR actually has a game plugin, so it's called Game OTR. You can download from cypherpunk.ca/OTR.
For people like hackers, I would absolutely recommend many of the open source plugins for instant messaging, like OTR, like Game E. I would not recommend using any of the software that I've mentioned that I've written, like Blame. Blame has been very outdated since it was written. For example, I didn't actually use any libraries for implementing the RSA or the Diffie-Hellman for that. I implemented it myself. I did it as a joke. But at the time, a lot of people were taking it seriously, and when it was recommended as the only solution to having your messages encrypted, I mean, you know, you go with what you have. But yes, you're right. For the people in the audience, aside from people who are representing businesses right now, I would absolutely recommend an open source client, deniable keys, deniable identity, and things like that. And for that, I would even recommend a more robust peer-to-peer networking where the actual client doesn't send the message from one user to another, but actually relays it through a number of users, like Mixmasters, for example, for what do they call it? Anonymous relays. Is there anything else? Okay. Anybody else? Anybody? All right. Well, I guess that's it. Thanks for having me.